Hi, today I will talk about Gen2 tag structure and how the data is stored and how we can represent tag values in different formats. First of all, let's talk about Gen2 memory banks. Gen2 tag has four distinct and well-defined memory banks. Each memory bank is also commonly referred as memory area on the tag. And first of all, the user memory is an optional memory bank in Gen2 tag. Most of the tags don't have it, and most of the time you will never ever have to deal with it. This memory allows user to store more information besides standard EPC tag value, and the size of the memory bank is totally tag dependent. The TID memory stores tag identifier, which identifies the manufacturer of the tag. The EPC memory area is what we commonly refer to as a tag value, and it's 12 bytes or 96 bit in size. The reserved memory bank is where access password and kill password is stored, and if you are using Gen2 tag, then you may be familiar with it. Now let's talk about how the information is stored in computer or even in RFID tag. The bit or binary digit is the most fundamental basic unit of the information storage. It is represented using either 1 or 0. Now 8 bits make up 1 byte, and 1 word is equal to 2 bytes or 16 bits. So sometimes you might have to deal with the word length, but most of the time you should not be worried about it. So how these numbers are displayed, or how we interpret them. So the decimal value is well known and we use it in everyday life, and it has the numbers or digits from 0 to 9. The binary numbering system is used in all the computers and all digital information storage systems, and it uses 2 digits, 0 and 1. The hexadecimal numbering system is widely used in computer science and mathematics for the notation purpose only, and it is made of 16 digits ranging from 0 to 9 and A to F. So once you go beyond 9, A is equal to 10 in the decimal number, B is equal to 11, C is equal to 12, D is equal to 13, 14 and 15. So 0 to 9, 10, 11, 12, 13, 14, 15. So why are we talking about this? Let's look at the example of decimal number 2138. We know what this numbers and we know the value, but why this value? So here look at it totally depends on the where the byte is, or I would say rather digit is placed in the sequence. So the 8 is the last digit in the number, so it has the least significant value. The 3 is the second digit from the right. It has a value multiplied by 10, and the subsequent values are multiplied by 10, or just increase the power of 10, or basically your numbering system base. It is very true for the binary number as well, and here you can look at the example. It is very similar to decimal, but we only use 2 as our base. And it is also true for hexadecimal numbering system. So if we have a number 1DA3, it translates to 7587 in decimal numbering system, and you can see the illustration of the example how it is being calculated. So now let's talk about ASCII code. ASCII is a character encoding schema for English alphabet, and ASCII code basically represents text, and this text consists of 128 characters, and it includes 33 non-printing control characters. Now the ASCII schema is still widely used and you can look up for the values for each keystroke you have on the keyboard from A to Z in capital letters, in small letters, numbers from 0 to 9, special characters, and many other things. So let's have a look at this. Okay, let me show you here. Okay, let me just open up. Okay, so this is the ASCII values. As you can see, the leftmost column is a decimal number, and this is equivalent hex values in the second column, and the third one represents the symbol. So for the ASCII value for capital letter A is 65 in decimal or 41 in hexadecimal, and similarly you can find all the ASCII values for any given character. And you might notice ASCII values from 0 to let's say 20 or in hex value or 1F is non-printable characters. So this is a null character, this is a tab value, this is a line feed, this is a carriage return, and so on and so forth. So as you can imagine, these characters are not printable as visible text. So let's continue our presentation. So let's consider the example of a tag value. It's 12 characters long or 12 bytes, and it has a tag value called NSYC RFID tag here. So what would be an equivalent hexadecimal for each character? So 69 is a decimal equivalent ASCII code for capital letter E, and so on and so forth for this row. In the third row, this is the same value, but it is in hexadecimal. So the first line, that's what I call a printable text value, and the hexadecimal row is considered pseudo hexadecimal value. And why are we talking about this? Because in a tag, all the values or all the information is stored in a binary format, but when you read it, you can interpret using as a number, ASCII numbers, just like you can read the value from the binary. It's a 45 hexadecimal value or 69 decimal value. Now you can treat it as a number, or you can convert or treat it as an ASCII code, and you can make it as a represent it as a character or a text value. So this is very important when we talk about the tag values, or how do you want to read it or how do you want to display it. So let's look at another example. Let's consider we have a tag value. This is all in hexadecimals: 41, 42, 43, 44, and then 21 to 24 and 51 to 54. So if you try to print it, or if you try to convert it in a printable text value, it would be A, B, C, D, and these are some values that you do not know, or Q, R, S, T. And let me just look up the numbers for you here. Okay, so 21 so here these are your 4 numbers or special characters that's not as part of A to Z or 0 to 9. So what would you do now? So it depends, like how do you want to interpret it. So let's consider the numbers, just regular like digits 0 to 9. It's a 7, 5, 3, 2. Here we have our tag value, and if you want to write this value into the tag, onto tag, so this is what you should be writing as a hex values. So this is what it will store: 37 hex value, 35, 33, 32, 34, and so on and so forth. So this is very important when we are talking about tag value. It can be meaning of it can have different meanings. It could be either hexadecimal value, it could be printable ASCII value, or you simply just want to use it as a decimal value, or if you just want to interpret all these numbers as a big large number. So it's totally up to you or end user how they want to interpret the value. But just to keep in mind, when we talk about hexadecimal, pseudo hexadecimal value, this is what we are referring to. When we are talking about printable text or printable ASCII value, this is what we are referring to. And this is just to keep in mind, and for all the applications you use, all the references we talk about on NSYC website, and for the development purposes. And thank you for watching, and thank you for being a valuable ANSYS customer.